Hello, this is Les, and in this video I will be discussing how I put together my vacuum chamber. This particular vacuum chamber I use mostly for degassing epoxies that have been mixed. It can also be used for degassing silicones as well, which is a fairly common use for this type of setup. Simply, we have the chamber itself, some plumbing, and the actual vacuum pump. The pump is, this particular style of pump is used for removing non-compressibles such as water vapor from air conditioning systems. When you get it though, it typically does not have a hose barb fitting on it. It has one of these. This has a R134A and an R12 fitting on it, which would be used with air conditioning systems to drain them down and to recharge them. It isn't terribly useful for connecting vinyl hose to. The hose barb is much better for that. So with mine, I removed the fitting. These are all 1/4 inch NPT threads. They are tapered threads, so that as they are driven down, they actually seal. The spaces between the threads actually fill. Traditionally, you would put something like a Teflon tape on the threads to both lubricate it so you can actually get it in tighter and to fill up some of the gaps. However, when these are mass-produced, they actually put a glue or epoxy on here, so it does prevent the air from coming out, but it makes it very difficult to remove. With mine, I removed the exhaust port and this plastic handle which covers the start motor capacitor on this particular unit. I clamped very large pieces of metal to this T-fitting and then use it as a lever. Unlike conventional threads, because these are going to have this epoxy glue substance on it, it doesn't immediately break loose and let go of all the tension, so it will still be difficult to turn for many turns trying to get it out. But once you've done so, you can take a hose barb fitting, and all these fittings are available at home supply stores like Home Depot or Lowe's or what have you. In both the air compressor section and the water department, the plumbing department, you'll find all of these. But once you've removed it, you can put on this fitting, the hose barb fitting. Now, once you've removed the old fitting, make sure to clean out any glue, epoxy, gunk bits that may have been left behind. There's actually a screen inside this housing to catch those sorts of things. So once you have that, we just have a standard vinyl hose. This goes from the inlet to, this is actually an air filter. I wouldn't actually put this back on if I had to do this over again. The air filters, this is designed for air tools with an air compressor, and normally it goes between the air compressor and the tool, which means this chamber is normally at high pressure. This valve, you'd normally push it in to let water drain out. But because we're drawing a vacuum, this chamber is now at low pressure, so this valve would be pushed in all the time. So in order to get this work with this system, I actually had to seal the bottom of this valve closed. It's just an annoyance. Here I tee off onto a pressure gauge. This is actually a gauge meant for measuring the intake manifold pressure of something like a car's engine. This isn't really useful. These are not terribly accurate at low pressure. It goes to 30 inches of vacuum, which would be a perfect vacuum, but you're never going to get one of those with this pump. And you'll be able to tell from the sounds the motor is making on your vacuum pump whether or not there's a leak and it's not actually getting a good vacuum or not. Something you will need, so these pieces aren't terribly necessary, but you will be needing one of these. This is just a simple valve to open and close. These pumps have check valves in them, so when you turn them off, they do not break vacuum, which is useful because since your vacuum chamber is at low pressure, what would happen is you have high pressure at the output, low pressure at the input, which means it would suck the oil from this pump back out the input, which would make a mess. Also, so that it's good that the check valve is there. However, because the check valve is there and it holds the vacuum, you need some way to get the lid off of your vacuum chamber. So if you open this valve, break the vacuum, it comes apart no problem. Here there's actually I installed a quick disconnect, and there's a separate cutoff valve for the chamber, so you could draw vacuum on the chamber, shut the valve, and then take it somewhere if that was necessary. But you really don't need it. To the vacuum chamber itself, this is actually just it's stainless steel, but this is a sheet metal pot from, I think, Bed Bath & Beyond. Almost any sturdy container will do. The top is a polycarbonate half-inch thick top that was just rough cut to fit this lid. The seal, this is actually a foamish rubber. This is actually the material that you use to keep your dishes from sliding around into your cabinets. So it's available at Home Depot, Lowe's, those sorts of places. It comes in a mesh version, which won't work, and the solid version, which does. Just cut it to about the correct size. When you put it on the chamber, when you run it for the first time, if you just give it a little push, when the vacuum grabs it, it will actually pull the lid down, and it will actually make these ridges in the foam, which you can use to stick it back on again, no problem. Getting the fitting in here is probably one of the most annoying aspects of a project like this. It's up there with getting this out. You'll want the fitting to seal onto this lid. Now, because we are drawing a vacuum, the forces in operation would be trying to pull the fitting into the container, not blow it out. But there are threads on this fitting, like all of these fittings. So you'll want to drill a hole through your top, ever so slightly bigger than the threads. Put this in here, and then the easiest thing to do will actually be to fill it with an epoxy of some sort. Again, these faces on this fitting will keep the whole fitting from being pulled in, but you do need to provide some type of seal here. So that will work just fine. As far as maintenance, there's very little maintenance to do on this type of system. The pump itself uses a special type of vacuum oil. This is not the type of oil you'd find, in a car's engine, motor oil, that sort of thing. So you almost certainly need to order the stuff, but you change it not because it becomes dirty, but because it becomes contaminated with water vapor or moisture. When the oil first goes in, it's perfectly clear, and you'll be able to see through the sight glass. You'll see that it's clear. It will eventually become contaminated with moisture. In arid environments, there's not that much moisture in the air, but in a very humid environment, there is. And in fact, when you first run the pump in a humid environment, you will see what looks like smoke coming out. It's actually steam. It's not burning oil. It's removing the moisture from the chamber, and you'll see it come out as steam. You'll know when you need to change it because the oil will go from being clear to having a white, cloudy look about it. And that is caused by the water that the oil has absorbed. This particular pump just has a drain valve here. You would drain it out. And again, on this pump, you would actually take this exhaust port off, and then you would fill the oil here. Your pump may vary, but they work similarly. A couple of points about using this type of system to degas. Frequently, when people are degassing these materials, they will have a big table with a bell jar that they will put on top of the stuff that they want to degas. Now, when the pressure in the chamber decreases, the air inside the substance that you wish to degas will start to expand, and it will cause bubbles. These bubbles can actually cause the material to overflow the container that you put it in, which is going to make a mess. To deal with this, they will burp the chamber, which is to say they will break the vacuum on the chamber momentarily to break the bubbles. What's actually happening is the air is surging back into the chamber, and when the air impacts on those bubbles, it disturbs them and breaks them. This is counterproductive because you are reintroducing air into the chamber that your pump's going to have to remove again. But you need some way to deal with the bubbles, or again, you're going to have a big mess. With this type of setup, this chamber, you can actually pick it up. So if you've put your container of your mixed materials in the bottom that you're degassing, you can actually pick the chamber up and swirl it around and disturb the bubbles enough to break them. If that's not enough, you can actually leave the stir stick you mixed them with in the first place in the container. And then when you spin the container, that stir stick will disturb the bubbles enough to break them. So it's completely unnecessary to burp the chamber to deal with the bubbles. I think that's about it. This isn't terribly complicated. Again, the filter, the gauge, the quick disconnect, these are all not terribly necessary. I mean, if you really wanted to, you could just have the hose go from the vacuum chamber to some type of valve to break the vacuum straight into the pump. Having the quick disconnect's kind of nice. You can take things apart and carry them one piece at a time. But that's basically it. If anyone has any questions, please let me know.